Hi, I'm Chiao-An from Purdue University, presenting our work, Learning to Obstruct Few-Shot Image Classification over Restricted Classes. This is a joint work with my collaborators Amber and Raymond. In recent years, open source models are becoming more powerful and prevalent. As the models are open source, anyone can fine-tune their own models with relatively low entry barrier. This leads to potential safety, fairness, and privacy concerns. For example, we may not want the models to identify our family members or make decisions based on certain features. To mitigate these risks, in this work we ask, is it possible to develop a pre-trained model that is difficult to fine-tune for some downstream tasks on selected classes but not others? Here, we denote the classes or attribute that we want to prevent the model from learning as R, while the others are denoted as R prime. For example, we do not want the model to learn the classification on devices but still excel on animal species. Or we do not want the model to be fine-tuned for detecting whether a person has a beard. The contribution of this work is as follows. First, we introduce the task of learning to obstruct, which is to limit the ability of a pre-trained model to fine-tune on certain classes. Next, we present LTO, a meta-learning algorithm for obstructing the learning of a set of downstream tasks. We show that LTO works for both classification and attribute learning. Here is an overview of our proposed pipeline. First, we need to define what R is in our data. Next, we illustrate the pipeline of fine-tuning a pre-trained model theta without our LTO. Theta is fine-tuned by a learning algorithm F and then evaluated for the performance on R and R prime. Now, with our LTO algorithm A applied to theta, we get an obstructed model A of theta. This obstructed model, even after fine-tuned by F, is not able to perform well on R. Our learning to obstruct algorithm is based on meta-learning, where we propose to learn difficult initialization for the downstream learner. The key portions of our algorithm are highlighted here. The gray line indicates F, the learner. The learner updates the model parameter and gather gradients based on whether the input belongs to R or R prime. We repeat this process several times to form a batch. Next, the pink line indicates A, the obstructor. The obstructor collects the aforementioned gradients within the batch. Finally, theta is updated with the aggregated gradients. To demonstrate the effectiveness of our algorithm, we propose two simple baselines for LTO by replacing the objective functions. First, we have only R, where we directly maximize the classification loss for only the restricted classes R. Second, we have no F, where we completely ignore the learner F in our algorithm and thus remove the updated tilde theta in the loss function. To evaluate how well our algorithm performs, we propose drop ratio as an evaluation metric. It is a ratio of accuracy drop of restricted classes R over other classes R prime. A higher drop ratio indicates a more effective obstruction. Here is an example learning curve. We can observe that although both the accuracy of R and R prime decrease, the drop of R significantly outweighs the drop of R prime. The drop ratio measures this contrast, so the higher the better. In our experiment, we apply LTO to different choices of SOTA learner F for few-shot image classification. We report the drop ratio of the two baselines and observe that LTO outperforms the baselines over various learners. We also conducted experiments on facial attribute learning. We define MAA prime as the ratio of the performance drop of one attribute to another. The higher MAA prime is, the more correlated they are. We visual the confusion matrix MAA prime on the selected attributes of celeb A. We want the correlation to be as low or blue as possible between different attributes, the non-diagonal terms. This indicates that LTO can effectively isolate and obstruct specific concepts. In summary, we propose and solve this novel task of learning to obstruct. Empirically, LTO successfully obstructs 4 few-shot classification methods over image classification and attribute learnings. LTO presents a method for making pre-trained models more difficult to be fine-tuned on certain tasks. This mitigates the risk of misuse for released models on known harmful applications, while maintaining the open source culture of the computer vision community. We believe that LTO represents a promising step towards this goal. Our code is available on GitHub. Please refer to our paper for more details. If you have any questions, we are happy to answer them during our poster session, October 3rd, 10:30, poster session 6. Thank you for listening.